The darkness of the outer solar system is not empty, it is merely waiting. For decades, the ice giants Uranus and Neptune have guarded their secrets behind a veil of immense distance and faint reflected light. While Jupiter and Saturn, the gas giants closer to our own warmth, have boasted moon counts in the nearly hundreds, the Uranian system seemed for a time relatively quiet. But silence in astronomy is rarely an absence of things. It is usually an absence of seeing. That silence was shattered, or rather gently pierced by a faint point of light that would come to be known as Uranus XXVIII. The discovery of Uranus XXVIII, provisionally designated S-2023-U1, marks a pivotal moment in planetary science. It is not a colossal world of geologic upheaval like Triton, nor a cracked icy wonder like Enceladus. It is a tiny, charcoal dark rock, barely 8 kilometers or 5 miles across. Yet, its discovery represents a triumph of observational technology and perseverance, earning it the title of the smallest moon ever detected around an ice giant from a ground-based telescope. Today on G Fun Facts Online, we are diving deep into the journey of that discovery, the nature of this tiny world, and what its existence tells us about the chaotic, violent history of our solar system. To understand the magnitude of discovering Uranus XXVIII, one must first grasp the sheer difficulty of the hunt. Uranus orbits the Sun at an average distance of 1.8 billion miles, or 2.9 billion kilometers. At this range, the sunlight is 400 times fainter than on Earth. Any object orbiting Uranus is illuminated by this meager light and must reflect it back across the same abyss to reach our telescopes. For large moons like Titania or Oberon, this is manageable. They were discovered in the 18th century by William Herschel because they are hundreds of kilometers wide. But for a rock the size of a small city, the reflected light is so dim it borders on non-existent. The discovery of Uranus XXVIII was not a matter of simply pointing a telescope and snapping a picture. It required a technique known as shift and add image stacking, a method that has revolutionized our ability to map the outer solar system. Dr. Scott S. Shepard of the Carnegie Institution for Science, a legendary figure in the field of moon hunting, utilized the 6.5-meter Magellan telescopes at the Las Campanas Observatory in the high deserts of Chile. The process involves taking dozens of 5-minute exposures over several hours. In a single exposure, a moon as faint as Uranus XXVIII is invisible, lost in the background noise of the universe. However, Shepard knew the moon would be moving. By shifting the digital images to match the predicted motion of a moon around Uranus and then stacking them on top of each other, the photons from the moon land on the same pixel in the final composite, while the background stars and galaxies streak into blurs. This amplifies the signal of the moon, coaxing it out of the darkness. On November 4, 2023, the data revealed a candidate. A tiny speck of light, barely magnitude 26.7, millions of times fainter than what the human eye can see, was tracking with the planet. To put that into perspective, magnitude 26.7 is comparable to spotting a single candle flame on the surface of the moon while standing on Earth. It is on the very edge of what is physically detectable by 8-meter class telescopes. A single night's observation is never enough. To confirm a moon, one must determine its orbit. Is it truly orbiting Uranus, or is it a passing asteroid? Is it background noise? Shepard returned to the Magellan telescope in December 2023 for follow-up observations. Working with orbital dynamicists Marina Brozovic and Bob Jacobson at NASA's Jet Propulsion Laboratory, they managed to link the new detection to recovery images, which are archival data from 2021, taken by the Subaru telescope and Magellan, that contained the moon but had gone unnoticed. On February 23, 2024, the Minor Planet Center officially announced the discovery. Uranus had its 28th moon. Uranus XXVIII is a member of the irregular satellite population. To understand what this means, we must look at the architecture of the Uranian system. The moons of Uranus are divided into 3 distinct classes. First are the major moons, the 5 large round worlds like Miranda and Titania that formed with the planet, orbiting in the equatorial plane. Second are the inner moons, the small, packed cluster of moons like Puck that reside within the ring system. Third are the irregular moons, the distant, chaotic swarm. These moons orbit far from the planet, often in highly elliptical and inclined paths. Many, including Uranus XXVIII, orbit in retrograde, meaning they move in the opposite direction of the planet's rotation. Uranus XXVIII belongs to this third group. Its orbit takes approximately 680 Earth days to complete a single journey around the ice giant. It resides about 8 million kilometers from Uranus, in a region of space where the planet's gravity is weak enough that the Sun constantly tugs at the moon, perturbing its path. At an estimated diameter of just 8 kilometers, Uranus XXVIII holds the record for the smallest known Uranian moon, pending precise measurements of even more recently detected inner moon candidates by the James Webb Space Telescope. Before this, the smallest recognized moon was Cupid, at roughly 18 kilometers. The small size of Uranus XXVIII is significant because it fills a gap in our understanding. We see populations of tiny irregular moons around Jupiter and Saturn, down to 1 or 2 kilometers in size. Their absence around Uranus and Neptune was not because they didn't exist, but because they were too faint to see. Uranus XXVIII proved that the ice giants also possess collisional families, swarms of debris left over from larger moons that were shattered by comets or asteroids billions of years ago. Orbital analysis suggests that Uranus XXVIII is not a loner. Its orbital parameters, specifically its inclination and eccentricity, are strikingly similar to those of 2 other irregular moons, Caliban and Stefano. This suggests a common origin. It is likely that billions of years ago, a much larger object, perhaps 100 kilometers across, was captured by Uranus and subsequently smashed apart. Caliban is the largest remnant of this parent body, while Stefano and the tiny Uranus XXVIII are merely shrapnel from that ancient catastrophe. This implies a parent body breakup scenario where a heliocentric projectile, likely a comet, struck the proto-Caliban moon. The energy of the impact did not pulverize the moon entirely, but spalled off large fragments. Caliban remained as the core, while fragments like Uranus XXVIII were ejected into similar orbits. The existence of Uranus XXVIII reinforces a dramatic theory about the early solar system known as the Nice model. This model posits that the giant planets Jupiter, Saturn, Uranus, and Neptune did not form where they are today. Instead, they migrated. As Uranus and Neptune moved outward into the Kuiper belt, the ring of icy debris beyond Pluto, their gravity acted like a snowplow. They scattered comets everywhere, some toward the sun and some into deep space. But they also captured objects. The irregular moons of Uranus are essentially captured comets. They were free-floating bodies in the early solar system that got too close to the migrating ice giants and were ensnared. The fact that Uranus XXVIII is retrograde is a smoking gun for this capture scenario. A moon that forms with a planet will almost always orbit in the same direction as the planet spins. Only a captured object would approach from the wrong direction and be locked into a backward orbit. The darkness of Uranus XXVIII also tells a story. Unlike the shiny, water-ice surfaces of the inner moons, the irregulars are often dark and reddish. This ultra-red material is thought to be organic compounds called tholins, baked by cosmic radiation over billions of years in the deep freeze of the Kuiper belt before their capture. Uranus XXVIII is likely a piece of primordial solar system chemistry, preserved in deep freeze. Its albedo is estimated to be around 0.04 to 0.07. This means it reflects only 4 to 7% of the sunlight that hits it. It is darker than fresh asphalt. We are essentially looking for a piece of coal in a cellar, at night, from 3 billion kilometers away. One of the most charming aspects of Uranian astronomy is its naming convention. While the moons of Jupiter are named for the lovers and descendants of Zeus, and Saturn's for the Titans, the moons of Uranus are named for characters from the works of William Shakespeare and Alexander Pope. This tradition began with William Herschel's son, John Herschel, in 1852. It has given us moons with names like Desdemona, Puck, Juliet, and Caliban. When Uranus XXVIII was announced as S/2023 U1, the speculation began immediately. As a retrograde irregular moon, it is generally given a name associated with a darker or more complex character, often from The Tempest or A Midsummer Night's Dream. In the years following its discovery, the proposed name Violenta, from All's Well That Ends Well, emerged as a favorite among the astronomical community, fitting the theme of the Caliban group, which often draws from the more tragic or obscure corners of the bard's folio. The process of naming is slow, overseen by the International Astronomical Union, but the identity of the moon as a character in the celestial play is part of its allure. The story of Uranus XXVIII did not end with its discovery. It was merely the opening chapter of a new era of ice giant exploration. Just over a year after the announcement of Uranus XXVIII, the James Webb Space Telescope turned its golden honeycomb mirrors toward Uranus. In late 2025, it detected yet another candidate, provisionally S/2025 U1, this time a tiny object embedded within the ring system itself. While that new object challenged Uranus XXVIII for the title of smallest, the significance of Uranus XXVIII remains unique because it was found from the ground. It proved that we do not necessarily need billion-dollar space telescopes to push the boundaries of the known solar system. We need large apertures, clever algorithms, and patience. The announcement of Uranus XXVIII in February 2024 was accompanied by the announcement of 2 new moons of Neptune, S/2002 N5 and S/2021 N1. The fact that these were found simultaneously is not a coincidence. It was the result of the same deep survey by Scott Shepard. Neptune is even further away than Uranus, making detection harder. Yet the new Neptune moons showed a similar pattern, captured, irregular, and part of collisional families. This parallelism is striking. Both ice giants have similar moon systems, despite their differences. Uranus is tipped on its side. Neptune has the massive captured moon Triton, which likely cleared out its original system. Yet, both have reacquired a population of distant, irregular junk. This suggests that the process of capturing irregular moons is a fundamental mechanic of giant planet formation, robust enough to survive even the chaotic history of Triton's capture or Uranus' great tilt. The discovery of these micromoons has added fuel to the fire for the planetary science decadal survey's top priority, the Uranus orbiter and probe. We have only visited Uranus once, with the fleeting flyby of Voyager 2 in 1986. Voyager missed Uranus XXVIII completely. It was too small, too dark, and too far away. The fact that we are still finding moons 40 years later from Earth suggests that the Uranian system is far richer than we imagined. A dedicated orbiter would not just count these moons, it would visit them. Imagine a spacecraft flying by Uranus XXVIII. What would it see? Is it a jagged shard of ice and rock? Is it a rubble pile? A loose collection of gravel held together by weak gravity? Like the asteroid Bennu? Does it have craters? Does its surface composition match the reddish tholins of the Kuiper Belt objects? Studying these small irregulars is akin to studying the fossil record of the solar system's formation. They are the unaltered building blocks of the planets, trapped in a gravitational museum. Uranus XXVIII is a speck in the void. To the casual observer, an 8-kilometer rock orbiting a planet 3 billion kilometers away might seem trivial. But in science, the extremes are where the truth hides. The smallest moon tells us about the limits of our technology. The retrograde orbit tells us about the migration of the planets 4 billion years ago. Its grouping with Caliban tells us of ancient collisions that shattered worlds. As we look back at the flurry of discoveries that began with S/2023 U1, we realize that the ice giants are not sleeping. They are dynamic, complex systems, teeming with debris, history, and mystery. Uranus XXVIII may be small, but its discovery cast a long shadow, reminding us that even in the darkest, coldest corners of the solar system, there is always something new to find if we only look long enough. The 28th moon of Uranus is more than a number, it is a beacon, signaling that the age of discovery in our own solar system is far from over.